Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning or good evening, everybody. Welcome. This is our first video in Igcse math series. I'm planning to explain all the math lessons for IG. I will start with O-level mathematics, and that will be not in the book order. Like I'm going to explain all the lessons, inshallah, but not in the order that came in the book. I will start today with sequence and sets. This is the first video about sequence sets. We will have another video. This one will be about sequences only. Another one will be about sets. That will be the whole chapter. Before we start, I would like you to make a like to the video. Don't forget to share if you didn't, and subscribe to the channel. Comment if you have any comments, if you have any requests, any questions, and turn on notifications to allow the video to reach you and all new videos as long as released. Okay, we'll start right away. Sequences are all patterns, or might be no patterns, just numbers, or set of any items. It has only one rule. It starts from the positive integers as its domain. Positive integers means the numbers 1, 2, 3, and 4, and so on, to any real number. Okay? Even it could be non-number items. But this is the most common form. Start with 1, 2, 3, 4, 5, 6, and here is the outcome will be real numbers. So the first term usually called the T1, second term is T2, T3, okay, and we are seeking in most of the sequence to reach a term called general term, or the Tn, or the nth term. In notation, we might use this way of writing T sub 2, T sub 3, or U sub 1, U sub 2, U sub 3, the same meaning. Okay, but we will need today to start with this problems from the main book for Cambridge. Draw a diagram to show how each of the following sequences continues and define the next 3 terms of each case. So the diagram means to know what is the term-to-term rule here. Like from moving from 5 to 7, what happens? Is that increasing by 40%, for example, or just adding 2? Usually 2 terms are not enough to recognize the rule. So you need to look at the next term. 7 to 9, it's also increased by 2. Is that happen again? Yes. From 9 to 11, I increase by 2. So the term-to-term rule is just adding 2 to each term to reach its next one. To write the next 3 terms, we simply add 2 again to 13. That will be 15, followed by add 2, 17, followed by add another 2, which is 19. These are the 3 terms. If he asks you to write the term-to-term rule in words, you simply write that, add 2 to reach the next term, or add 2 to any term to reach the next term. Okay, let's do the next one. 8, 5, 2, and so on. What's happening here? It's clearly decreasing sequences. Each term is less than the previous term, and it go down by 3. How to know these 3? Just subtract any number minus the previous number. 5 minus 8, the second minus the first is -3. This negative indicates that it's decreasing by 3. Also, -4 minus -1, of course, you know that it's like 4 plus 1, which is also -3. So -3 for all terms. That means the term-to-term rule is to subtract 3. So I will add -3 or subtract 3, the same mathematical meaning, of course. Subtracting -3 for all. So I will keep subtracting -3 to reach the next 3 terms. -4 minus -3, that's like sorry, -4 minus 3, sorry, it will be -7. And -7 minus 3 is -10. That's minus 3 is -13, and so on. Okay. So next one, half became 2. For half to be 2, it will be increasing. 2 is 3.5, it's increasing. I think with the same amount. This amount is how much? I subtract 2 minus the previous term. So it's 1.5 in positive. So it's increasing sequence by 1.5. So from term to term, I will add 1.5. When adding 1.5 to each term, that means here I will add 1.5 as well. So it will be what, 6.5 plus 1.5? It's just 8. Add 1.5 to that 8 to be 9.5. And after adding 1.5 to 9.5, it will be exactly 11, and then 13.5, and then so 12.5, and so on. I only need 3 terms. Last one, oh my God, it contains a lot of decimals. It seems decreasing, but is that a fixed number? Let's try that. First, I will subtract the second term minus the first. So it will be 2.3. Sorry, 1.1 minus 2.3. That will be negative 1.2. Continue with that. Is negative 0.1 minus 1.1 is the same? Yes, negative and negative. That will be negative again, and add both numbers. So it's pretty consistent. And the negative 1.3 minus negative 0.1 is like adding 0.1 to negative 1.3, which will remains negative 1.2 again. So subtracting 1.2 is the rule here. Or adding one negative 1.2. Doing that or that will allow you to find all the terms. So by adding negative 1.2 here, it will be negative 2.5. Add again negative 1.2 here, it will be negative 3.7. Then add again negative 1.2 here, it will be negative 4.9. These are the 3 terms that the question is asking about. Okay, feel free to make any comment you need, and I will answer all the questions you have. Let's go to the second question. Here he tells us find the next 3 terms. Okay, same as the previous question. And this case, the rules will be not a very tricky, but a little trickier than before. So the first sequence here, it's 1, -3, then 9, then -27. Doesn't seem that it is increasing or decreasing. So if you try to find the difference between -3 and 1, it would be -4, but from -3 to 9, 9 minus -3 is plus 12, it's increasing. So down and up, that cannot be an easy rule to write here. But if you look in another point of view, if we multiply 1 by 3, then multiply 3 by 3 again, and by 3 again, I can find 1, 3, 9, 27, and 81, the next one. Multiplying by 3 is a good, but what about the negative here? This negative sign alternates. Alternating means a term is positive, the next is negative, then the next is positive, then the next one will be negative again, and it clearly remain alternating this way. So instead of multiplying by 3 to reach this alternating negative situation, I will multiply by -3. Multiply by negative number will allow the sign to alternate. So 1 times -3 is -3. And what about -3 times -3 again? It will be +9, right? So multiply by -3 again will be -27. Then I will keep multiplying by -3 to be 81. Then multiply that by -3 to be 143 in negative. multiply that by -3 to be positive 729. I only need 3 terms, so I will stop here. So the term rule here is to multiply by -3, constant multiplication. Pretty nice pattern. So this one, the outcome is not real numbers. It could be any item, as we said. So, but it is in alphabetical order: A, B, C, D, E, F, G, H, Y, J, K, L, M, N. You know that. So from A to C, he missing one letter here. Is that a mistake? No, because from C to F, he didn't missing one letter. He missed 2 letters. So let's try to write that here. A, he missed B. C, he missed A, B, C, D, E, and here I F. So he started with missing one letter, then he skipped 2 letters. Is he skipping 3 letters after that? Let's see what's after F. A, B, C, D, E, F, G, H, I, J. Yes, he missed 3 letters. So I guess you know now that he is going to miss 4 letters: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. So he missed 5 letters. Now he is going to miss 6 letters. Okay, and I know the term here is U. I need 2 more terms. I don't have enough alphabet for that. We'll try to make a trick. So what after V? S, T, U, V, W, T, U, V, W, X, Y, and Z. Here 5 letters. What's the next letter after Z? I will act like Excel sheet now. It will be AA. So the next will be AB. A, B, C, D. Okay. And I can consider AB is a term. And I'm going to miss now how many letters? 1, 2, 3, 4, 5, 6, 7 letters. Skip 7 letters after AB. So it will be AC, AD, AE, AF, 1, 2, 3, 4, still AF, AG, and H, 1, 2, 3, 4, 5, 6. I need to miss or to skip one more letter. So it will be AI. And the next term will be in the sequence should be AJ. So this is my answer. Pretty nice pattern. I hate it anyway. Okay, next one, also a very tricky one. It's 1, 2, 2. Might look pretty weird why 2 is not increased or decreased here. And then 4, 3, 6, 4, 8. Oh my God. It go down and then up and go down and then up. So it keep going up 1, then 0. Here, no change. Then up 2, down by 1, up 3, down by 2, up 4. I think it will be down by something here. But let's see if we look at this alternatingly, like 1, 2, 3, 4. This called odd number terms. Like the order is 1, 3, the first, third, fifth, seventh. That's why we call that odd numbers. And even number terms, these are the terms. So if we follow the blue pattern, the next would be blue, of course, because, and the one after that would be yellow again, and then back to blue, and I don't need more terms than those. So from 1 to 2 to 3 to 4, it's pretty simple, increasing by 1. So I think here should go with 5, and here is 6. Okay. Now what is the term in yellow? 2, 4, 6, 8. Pretty recognized. Okay. It's even numbers. 2, 4, 6, 8. So the next even number would be just a 10 here. And of course, I want to continue that. I will write 12 after 6 because it will follow the yellow pattern. Okay. I skipped some questions from the book that because it looks pretty easy for me, the repeated ideas as those. So I will leave some for you. If you need me to solve the full questions, just mention that in the comments, and I will do that on all the next videos, inshallah. Okay, find the 15th and nth term for each of these sequences. Okay, let's try to find the 15th term. So am I going to write 15 term? It will be a pretty long answer. So I will go to the nth term first. Then I can find the 15th term or any other term easily out of that nth term. What is the nth term? It's just a rule of the function or the sequence. Just pretty much like the function. Rule depends on n, but when you substitute the order n, you can find the value of the term. Like when you substitute 1, I need to see 5. When I substitute n equal 2, I want to reach 7. At n equals 3, the value should be 9. At n equals 4, the value should be 11, and so on. So n is the order of the term. The nth term value is the term itself that appears in the sequence. I have 5 terms here to use in finding the next term and finding the nth term as well. So let's see what's the method here. From 5 to 7 to 9, I pretty clearly adding 2 each time. I can write any number of terms you want. The 15th term is not a big deal. I can add more 10 terms here to reach the 15th term and get this mark. But let's see how to get the nth term first. The nth term, I will call that Tn. Okay, or Un, both are pretty correct names for the nth term, Tn or Un. Some books used An, the same. Tn will be depending on n this way. If your sequence depends on adding a fixed number or subtracting a fixed number, this number will be like gradient of n, the coefficient of n. I add here 2 plus 2 plus 2 plus 2, so I start with 2. Okay, is that the rule? No, because if you substitute 1 here, the result is not 5. If you substitute 1, it will be 2 times 1, 2. 2 to be 5, you need to add 3 to fix this error. So this is the 10th term. Let's try substitute n with 2. 2 times 2 is 4. 4 plus 3 is 7, so I got 7 correct. So can I get 9 from substituting n with 3? Let's see. 2 times 3 is 6. 6 plus 3 is 9, so that's correct. So I would consider this is the correct nth rule and find T15 accordingly. So from this one, I can write T15 as 2 times 15. The order is 15 plus 3. So this term will be 33. So now we can find the 15th term and the nth term as well. I will repeatedly do that in all the next and the followed questions. So number 2 here, 8 became 5, became 2. So I will subtract 3, subtract 3, subtract 3, subtract 3, and keep doing on. So the Tn, as we learned, will start with 3. No, I subtract 3. So it will be negative 3n. And if you substitute n equal 1, negative 3 is not 8. So you need to add 11 to that negative 3. Why? To make it 8. If you think this, it's hard to be seen, this 11, you simply find the term that might be before 8. Like if the first term is missing here, how much will that be if there is any term before 8? because the sequence is decreasing, the term here will be more than 8 with the same difference. So add 8 and 3 to find out this could be 11, 8 plus 3. As well as here, the first one, he is adding 2, adding 2. So if any term should be written before 5, it should be 3. Plus 3 plus 2 is 5, 5 plus 2 is 7, and we keep adding 2 after that. So this previous term here will appear in the nth term. You see that? So this 11 here will appear in the nth term as well. So two numbers appeared in the nth term. The fixed difference with the -3 and the number I call that zeroth term, the term before the first. Okay? Keep checking this nth term always after you find it. Like if you substitute n equals 3, you should reach the third term, which is 2 here. Let's try that. -3 times 3 is -9. -9 plus 11 is 2. Okay, substitute n equal 4. -3 times 4 is -12 plus 11 is -1 again. So 2 and -1, and I think -4 also will appear. So T15 can be reached by substituting n equal 15. -3 times 15. And don't forget to add 11. So -45 plus 11, it will be -34. Okay? This is the 15th term. Next one. Half 2, it's increasing by 1.5, then 3.5. Again, I add 1.5. So let's think about the term before that, by the way. If I subtract 1.5 from half, it will be negative value, -1 exactly. Just simply find half minus 1.5. So the nth term, as we just learned, will be this 1.5 times n, and add this previous term, -1. Check if that is correct for all terms or not. Like, of course, correct at n equal 1. 1.5 minus 1 is half. 1.5 times 2 is 3. 3 minus 1 is 2, exactly. So, and what about 3.5? 1.5 times 3 is 4.5. 4.5 minus 1 is 3.5, so that works perfectly. Now I'm going to substitute 15 to get the 15th term. It will be 1.5 times 15 minus 1. 1.5 times 15, like 15 times 15 with a decimal point. So it will be 22.5 minus 1, it will be 21.5. Forgive me if I made any silly mistakes, because there is no preparation for the solution. I just solved that with you. And Tn. What's Tn? I would like you to pause the video now and try to find Tn yourself and find the 15th term, and then continue watching to know the correct answer. Okay? I consider you done that. Tn will be what's the fixed difference here if we have any. To find the fixed difference, in this case, it will be so tricky for you. So I prefer to subtract the second minus the first. See, 4.8 minus 6 will be -1.2. So I will subtract 1.2. So I will start here with -1.2n. And I will keep subtracting 1.2. The term is not changed, the same rule, -1.2 to reach 3.6 and -1.2 to reach 2.4 and so on. So I only now need to add the first term, which is the first or the zeroth term, the term before 6. So if you add 1.2 to 6 to reach the previous term here, it will be 7.2. So adding 7.2 is the last part of your answer. Sorry. And T15 this time will be -1.2 times 15 and add 7.2. How much is that? We might use a calculator here. Sorry for that. I will write negative 1.2 multiplied by 15 and add 7.2. The answer will be negative 10.8. Okay, so negative 10.8 is the 15th term for this case. Okay, let's move on. Consider the sequence, this one here, find the nth term. Okay. I need to recognize the term-to-term rule first. From 4 to 12, from 12 to 20, it seems to add 8. From 20 to 28, yes, he adding 8. From 44 even to 52, he is adding 8. So I add 8. This is not the rule, this is the term-to-term rule. Okay, to move on from term to term, we add 8. So the nth term, Tn, should be 8n, and also add the number that should be directly before 4. If you subtract 4 minus 8, it will be negative 4. So this is the nth term. I will use that to find the 500th term. That's called T500. Of course, I'm not going to write all the 500 terms, but I'm going to use this nth term by substituting n equal 500. Okay, so it will be 8 times 500, which is 4,000 minus 4, 4,000 minus 4, which will be 3996. Okay, this is the 500th term. So that's why the nth term is pretty important. It saves a lot of time instead of finding 500 terms. Now, with pretty main ideas, what should we do if he give you the term and ask you about the order? And if that term ever appear in the sequence or not? So here's the trick. We also use the nth term, but here, number C, I'm going to substitute the Tn itself with 236 because he said there is a term equal to 136. Okay, what was that term? I need the order. Which term? So I start by solving this 236 equal to the nth term, 8n minus 4. Solve that linear equation normally. I will move this 4 to the other side. It will be plus 4, adding 4 for both sides. And that will be 240. If that's equal to n, I need to now divide by 8. If I divide by 8 here, 24 divided by 8 is 3. So this will be 30. And here is n. So the answer here should be the 30th term, the term number 30. Okay? Or T30, or U30. All these are pretty correct answers in the test. Okay, now with number D, I will erase this part here to make some space to write the answer. So what's about this case? Is 154 ever appear? Is not a term or is a term? We'll see. Now with number D. Let's check if I continue solving this equation, what value of n we can find. It will be 154 plus 4, 8n. 158 equal 8n. This number is not divisible by 8. If you try to find n now by dividing everything by 8, you find a very weird and unacceptable value for n. If you divide that by 8, it will be 19 point whatever. It cannot be a value of n. We said in the first thing that the sequence should start with a positive integer. So n should be a positive integer. It cannot be 19.75. It cannot be. So that's enough solution. There is no term equal 154. No term equal 154 in this sequence. Okay? So if he asks you to prove that there is no term, or 154 is not a term in the sequence, just solve for n, and you will find n either negative or a fraction value that cannot be integer. So you refuse it and say no term equal this 1.4, this 154. So let's read the next question. Not all sequences progress in the same way. It might be increasing or decreasing by a fixed constant added or fixed constant multiplied or divided. But here it will be a little weird. We'll learn how to recognize the nth term for each case here. If the first term here is half, followed by 1/4, followed by 1/8, 1/16, and so on. So the fraction consists of two parts, the top and the bottom parts. The upper part here is fixed as 1. So I believe that the 10th term, Tn, will be with 1 up. What else we have down? We have a sequence that increasing, but with not a fixed difference. 2 times 2 is 4. That's factor. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So I keep multiplying by 2. In this type of sequence, 2 times 2 times 2, that's called repeated multiplication, or a power form. So it should appear here is 2 power n. Is that set, or we need to multiply by other constant or add other constants? Let's try 1, 2, 3, 4 and see if we get all these terms or not. T1 here will be 1 over 2 power 1, which is half. T2 will be 1 over 2 power 2, which is 1/4. That works fine. If n equals 3, it will be 2 power 3, which is 8 down here. So that's nice. I can consider that is done now. If we can find here different numbers, allow yourself to multiply here by 2 or 3 or something to fix this error if that happens. Okay. Let's see the next one, number B. What's Tn in this case? Again, it's a fraction. The top here, 3, 7, 11, 15. Pretty nice. Followed by term to term rule is just adding 4, adding 4, adding 4. So this adding 4 will make the first rule up here start with 4n. And again, what term you think is about to be preceding term to -3? What's the term before 3? So the 3, if we subtract 4, it will be -1. So it starts with 4n minus 1 up. If you try n equal whatever value you need to check, you'll find it correct. The bottom part is 8. 11, it's adding 3, and 14, add 3 again. So again, it's start with 3n. And this 3n is what? Plus, yes, 8. What is the preceding term for 8? That term before 8. If you subtract 8, it will be, if you subtract 3 again, it will be 5. So it will be plus 5. Check. N equal 1 is 8, n equal 2 is 11, correct. So this is the last form. If this term can be simplified any further, do this simplification, not leave it complicated. But in this case, no simplified can be found easily. So I will go now to number C. Okay. 9 over 64. 49 over 121. 121, these numbers are pretty famous. Those are all perfect squares. Actually, 3 over 64 is the same as 9 over 64 is the same as 3 over 8 and all squared. Right? 3 power 2 is 9, 8 power 2 is 64. The next term also is 7 over 11, 7 over 11 all squared. And the next one will be 11 over 14 all squared, and so on. Oh my God. Look at that. 3 over 8 is the same as the first term here. Also, 7 over 11 appears, and 11 over 14 also appear. So the next one, pretty clear, 15 over 17 squared. So I can find the 10th term relying on the previous question. It will be the same nth term, 4n minus 1 over 3n plus 5, but all squared, and that's it. Same term. Of course, you can redo the following of 3s and 7s and 11 and write the top as 4n minus 1 all squared. The same. Okay, for last one, number D. Now it's pretty tricky. 3, 6, 3, 6, 3, 6. So I can say it's a 3, 6, 3, 6 forever, like alternating. But what about the top rule? It's -2, -1. Let's go up by 1, then down by 2, then up by 3, then down by 1. Doesn't seem to have a very consistent pattern here. But let's think differently. If I make all the fraction with the same denominator, that will mean I will leave these 6's and convert every 3 to 6 by multiplying up and down by 2. That will be like this. First term will be -6 over 6 over, sorry, multiplied by 2, it will be -4 over 6. I multiply by 2 up and down. I will leave the second term as it is. Third term, again, I will make that over 6, so I'll multiply up by 2. Leave this fourth term. Fifth term, again, multiply by 2 up and down. Now I can see we have the same denominator, but now the term up is easier to predict. -4 goes down by 3, no, goes up by 3, I add 3. -1 to 2, I add 3 again. From 2 to 5, I add 3. From 5 to 8, I add 3. So the 10th term should be something over 6. What's that thing? I simply add 3. So by adding 3, that means the start is 3n, and of course the term before -4, I will subtract another 3 to be -7. Now try all the numbers you want for n, it will work perfectly. Of course, if it give you 2 over 6, you need to simplify that to 1/3. For example, if n equal 5 here, 15 minus 7 will be 8. 8 over 6 is this term, which can be simplified by cancellation. Just cancel the common factor 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So this works for the whole terms. I hope you enjoyed that. Next one. The first 3 terms, this will be pretty easy, and the 20th term for each sequence. So I will just substitute n equal 1, n equal 2, n equal 3, and n equal 20 at that. 4 requires, okay? T1 here will be 4 minus 3 times 1, which is 4 minus 3 is 1, correct? And T2 will be 4 minus 3 times 2, which is 4 minus 6, or -2. Third one will be 4 minus 3 times 3, which is 4 minus 9, which is -5. So it will be 1 followed by -2 followed by -5 is go down by 3. That's why the gradient or the coefficient of n here is -3. Finally, I need to find T20. So for last term, I substitute n equal 20 here. That will be 4 minus 60. And 4 minus 60 is negative. What 60 minus 4 is 54. So these are the 3 answers for the first 3 terms, and this the last one here for the 20th term. Okay? Because there's no room in this page, I will erase this answer and think in the rest one by one. Again, if you need to get the most of the video, please pause and try to solve the next yourself first. Okay, I will erase these parts here and then redo the next one, or go for solving the next one. Here, Tn, I need T1 will be half times 1 squared, which is half. T2 will be half times 2 squared, which will be half of 4. Half the 4 is 2. T3 will be half times 3 squared, will be 9 over 2. T20 will be half of 20 squared, which is be 400 over 2, or simply 200. So here is the answers. Again, correct that to yourself. Okay. For the next one, again, pause and try to solve it. Now with number 3, T1 will be 1 multiplied by 1 plus 1 multiplied by 1 minus 1. 1 minus 1 is 0, so the first will be 0. What's T2? It will be 2 times 2 plus 1. I just replace n with 2 times 2 minus 1. So it will be 2 times 3 times 1, which is 6. T3 is 3 times 3 plus 1 times 3 minus 1. So it will be 3 times 4 times 2. 3 times 4 is 12. 12 times 2 is 24. And the 20th term is 20 times 20 plus 1 times 20 minus 1, or 20 times 21 times 19. How much is that? It's big enough to use a calculator. So 20 times 21 times 19. Sorry, times. It will be 7,980. And here is the final answers. And again, correct yourself. Give yourself a mark out of 4 for each question, and then find this total to know how long is your understanding, or how much you understand this. Last one here, T1 is 3 over 1 plus n, or 1 plus 1, which is a fraction 3 over 2. This is the simplest form for that. T2 will be 3 over 1 plus 2, which is 3 over 3. Can simplify that to 1, of course. T3 is 3 over 1 plus 3, which is 3/4. Simplest form again. T20 as he asked for will be 3 over 1 plus 20, which is 3 over 21. That can be simplified to 1/7. 5 by 3 up and down. So here is the final answer: 1 over 7, 3/4, 1, and 3 over 2. Consider putting the system in the simplest form is a part of the question. Okay. Anyway, he didn't ask for the simplest form. Okay, let's move to the next question. He gave us this form of questions. If x plus 1 and the negative x plus 17 are the second and sixth terms of a sequence with a common difference of 5, find the value of x. Find the value of x. So I have a sequence that starts with whatever, but the second term is given, x plus 1, second term. He said this is the second term that came after the first. Okay, what else? He's adding unknown terms to the sixth, so the third term is not given. The fourth is not given. The fifth is not given, but the sixth term is given. How much is that? Negative x plus 17. Okay. This is the sixth term. So it should go here, here. So this is the first, this is the third, fourth, fifth, and sixth term is going here. But he gave us this word, a common difference is 5. That means you add 5 from term to term. So let's try to find the sixth term again using this rule. From here, I add 5 to reach this value. So x plus 1 plus 5, it will be x plus 6. Add 5 again, add 5. So x plus 6 plus 5 is x plus 11. And when adding 5 again, x plus 11 plus 5 is x plus 16. So this one should be x plus, add 5 again, it will be 21. So if this x plus 21 is the same as the sixth term mentioned in the given, which is negative x plus 17, that will create us an equation that will allow us to find the value of x. By solving this equation, I will isolate all x's in the same side. So this negative x came here with the opposite sign, and the 21 will go to the next side to be negative 21 plus 17. So here is 2x, and here is negative 4. That reveals the value of x is divided by 2 to be just negative 2. And that's the required. Okay. This one is the same, pretty much like the first one, but I think he has a mistake here in the book. Why? Because he mentioned the third term is the first, the second, the third is given. Sorry, plus 4. And I miss the fourth, the fifth, the sixth, and again, he gave us the term of order 7, the seventh term. So third, fourth, fifth, sixth, seventh. And the term to term rule, he gave us a common difference of negative 2. So I add negative 2 here. I add negative 2 from term to term. X plus 4 minus 2 is x plus 2. Minus 2 is x, minus 2 is x minus 2. Minus 2 again, it will be x minus 4 again. There is no way to find a single solution for this equation. If I make this x minus 4 here, like x minus 4 we reached here, which is x minus 2 minus 2. Like I reached that from the given ones. And once again, from this rule, x minus 2 minus 2, it will be x minus 4. So this is always true situation, always true equation. It has infinitely many solutions. That means any value of x will work. Any value of x works. Like x equals 7 will make a correct situation here. X equals 20 is okay. X equals negative 20 is okay. Any value of x is good. So x could be any real value, any real number. So that's why I think there's some mistake in the book. If this x minus 4 is modified to like negative x plus 10 or whatever other situation or other term, we can solve for x like we did in the last question. Okay, this one, pretty easy question after all this fight. Write down the next 3 terms only. So pretty easy one. 3 became 7. He is adding 4, adding 4, adding 4. So what should we do? We will add 4 3 times to 19. Okay. So 19 plus 4 will be 23. Plus 4 again, 27 plus 4, 31. Next one, he's adding how much? Not 5. He started with 5, yes, but next he didn't add 5. He add 7. Then he add 9. Oh my God. He add 5, then add 7, then add 9, then add 11. So I can conclude that he will add 13, then add 15, then add 17. I will follow the odd number pattern here. So by adding 13, it will be 49. This is that term. Add 15 to that, it will be 64, another term. Add 17 to that, it will be 81 as third term. You know, the nth term here will be just something squared, like n plus 1 squared, I think, because all of them are perfect squares. It's not n squared because it starts with 4. So n plus 1 is 2, 2 squared is 4, n plus 2, when n equal to, it will be 2 plus 2, 2 plus 1 squared, 3 squared is 9, and then 3 plus 1 squared is 16, 4 plus 1 squared means 5 squared, 25, and so on. So this will be the nth term for the second one. Okay, about the last one. 23 goes down this time by 4, and goes down by 6, and go down by 8, by 10. Oh my God. So it's keep decreasing fixed even numbers. Okay. So I subtract 6 here. I subtract here. And here's 6, here's 4. And here's 8, and here's 10. So I think he will subtract 12 to reach the next term. Then he will subtract 14, then 16. And we can find the missing terms this way. So negative 5 minus 12 will be negative 17. Negative 16 minus that, minus 14 will be negative 31. Negative 31 minus 16 will be negative 47. Okay, so these are the answers for the first one. Well, I have a very messy number. Here is the answer for the second one. And lastly, this is the answers for the third question. Negative, negative, negative. Okay, I hope you understand that. We'll move on now to the patterns. I'm not going to draw all the patterns in the book, but I will make you learn about the patterns a little bit. Okay. Here, famous patterns, the pattern of perfect squares. You need to memorize the first sequence here, 1, 4, 9, 16, 25, and so on are called perfect square numbers, the numbers that have a square root. The nth term for this sequence will be n squared. Okay, the nth term is n squared. And some sequences might appear in the test that not exactly like this, but related. For example, if you multiply all the terms by 2, 1 times 2 is 2, 4 times 2 is 8, he will generate a new sequence like 2, 8, 18, 32, 20, or sorry, 50, 72, 98, which is twice 49. So this will be simply the double of perfect squares number. So the general term will be 2n squared. Next one, 3. He is adding 1 to 2. No, he's adding 2 to 1. I'm not sure. Let's see the next term, 6. Oh, he is adding 2 to 4 now. 11 is adding 2 to 9. And 16 plus 2 is 18. Yeah, 25 plus 2 is 17. That's, I think, good guessing. And the nth term will be n squared plus 2. Okay? It might get any other form, but all based on n squared. So either n squared multiplied by a constant or added to a constant. These forms happen almost in every single test. There's much harder forms that never shows in tests. And if you need to learn about harder examples, just let me know in the comments. I will make a video for very hard sequences that need to get the general term out of it. But that will be like extracurricular, not in the curriculum. Okay, in the curriculum, he used only n squared with very simple modification. Okay, so that all came when you memorize this sequence here pretty well. Okay, if you have a doubt that the sequence he used in the exam is following second degree or square numbers, write the square numbers and look at the sequence. You will recognize the relation between them and find the answer. Another one here that you need to memorize is the perfect cube numbers, the number with a cubic root, like 1 power 3, 2 power 3, and so on. This is called cubic numbers. Of course, cubic numbers can carry negatives, but perfect square must be in positive. Anyway, if 1, 8, 27, 64 appears, it will be n cubed. And also, it can multiply that by 2. 1 times 2 is 2, 8 times 2 is 16, 27 times 2 is 54, and so on. That will be a sequence of double cubic numbers. And last one, he adds just a fixed number to all cubes. 1 plus 2 is 3, 8 plus 2 is 10, 27 plus 2 is 29, 64 plus 2 is 66. So adding 2 will create a new sequence with a general term of n cubed plus 2. If you need any term, of course, after that, you just use n. Okay? And again, you need to memorize the perfect square and the perfect cube numbers. And this last one, you need to memorize called the triangular numbers. Okay? As you see, he is adding 1 to all the natural numbers, for the positive integers. So 1 plus 1, or 0 plus 1 is 1, the first one. Then add 2 to be 3, add 3 to be 6, add 4 to be 10, then add 5, add after 5 we add 6, then add 7, and so on. The general term is either be n squared plus n, or n times n plus 1 over 2. N squared plus n over 2, or n times n plus 1 over 2. Okay, you need to memorize this sequence and memorize its general term. And again, it has a lot of varieties here, but it is outside the book. If you need that, mention that you need more practice on like strange patterns and how to get the nth rule if this is not a simple pattern. Okay, mention in the comments whatever question came up to your mind. Okay, here again I will use the rule to find 3 terms and the 25th term. Now he used the notation u sub n. U sub n or t sub n are both okay. I will go with u now. So what is u1 in the first one? Again, pause, because this question we just solved one pretty much like it. So try to pause and solve that yourself first. I will go to the answers directly. u1, it will be half plus 1, which is 1.5 or 1.5. u2 is 2 over 2 plus 1, which is simply 2. And he will add half, so I think u3, if you substitute 3 over 2 plus 2, it will be 2.5. And u25, it will be 25 over 2 plus 1, which is 13.5. Okay. Next one here, u1 will be negative 2 times 1 plus 1, which is negative 1. u2, he will add negative 2. So that will be negative 3. And u3, it will be again negative 2 times 3, negative 6. Negative 6 plus 1 is negative 5. And finally, u25, as he requested, will be negative 2 times 25, negative 50. Negative 50 plus 1 is negative 49. Okay, next one, u1 is 1 squared, which is 1. u2 is 2 squared, which is 2. Pretty famous pattern. We just learned that. 2 squared, and 3 squared is 9. And finally, u25 is pretty big number, 25 squared. That's the 25 times 25. Okay. 625, not 15. This one is even much bigger. It's called for the exponential form. Like u1 will be 2 power 1, which is 2. u2 is 2 power 2, which is 4. u3 is 2 power 3, which is 2 times 2 times 2, 8. Imagine what is u25 value. 2 power 25. I prefer to leave that like this, because if you try that on a calculator, 2 power 25, oh my God, can you see this value? 33554432. Really nice number, by the way. 33554432. Oh my God. Okay. That's the power of exponential sequences or geometric sequences. Okay. Here, the number of 30 and 110 are found in the sequence. In which positions is each number found? Position here, he is asking for the value of n. Okay, so I will solve that by equating the general term and 30 and solve for n, and again repeat the same action but with 110 this time and solve for n each time. Here you have two ways to go. Either you expand and make a zero equation and factorize and get the value of n. Remember, n should be positive integer in both cases. And the other value is try to factorize this 30 into two numbers that differ by 1, because n times n minus 1 are two integers that differ by 1. So 30 is simply 6 times 5, right? If we consider this x, and this n, sorry, 6, and we consider n minus 1 is 5, because it's 1 below 6. So that reveals n is 6, or the sixth term is the term equal this value. So I can say that u6 equal to 30 in this sequence. Okay, or you expand like that, n squared minus n minus 30 equals 0, and solve. And you can find two values. One is 6, one is negative 5, because this n plus 6, minus 6, sorry, and the n plus 5. Of course, n equal negative 5 cannot be answered, but n equal 6 is good, and it is the sixth term. But I prefer to guess like the first way I did. Here also, 110 is pretty easy to be guessed. It's 11 times 10. By comparing that, you will see 11 is the bigger one, which is n. The lower one is 10, which is n minus 1. So simply n equal 11. So you can say that u11 is 110 in this sequence. Okay, we'll go to the next. Here, we will need to solve completely. No wait for a shortcut here. I will make this term equal 167 and solve for n. So 2n squared plus 5 equal 167. And move this n, this 5. I need to isolate n. Okay. So I subtracting 5 from both terms, from both sides. That makes 2n squared equal 162. Divide by 2. I need n squared to be isolated first. So that will be 81. Now taking the square root, the positive square root only, because I need a positive value for n. So it will be square root of 81, which is 9. Okay, you know that square root of 81 is 9, because 81 is 9 times 9. So u9 is the term with this value, and we are done. Next one. For the sequence, this determines the value of the 10th term. That's easy required. So EU10 means only substitute 10 instead of n. Okay. That will be 2 times 100. That's a 200. And the 50 plus 3. What's 200 minus 50? Is 150. 150 plus 3 simply would be 153. This is the first answer, number A. For number B, he needs the value of n, if any, that makes the term equal 54. So I will equalize this general term equal 45, sorry, not 54, 45. Make that a zero equation. I will move this to the other side in negative. The equation is a very important step when solving a quadratics. And then collect these like terms 42. No common factor, so I go to factorization. 2n and n. This 42 should be factored to 2 factors. I will choose 7 and 6. And we'll make 7 here and 6 there. I love to try the pretty close factors first. Anyway, it seems working pretty nice because 7 and 12 has difference of 5. So I will go make this one, the 12 has the bigger value, so it will go with the negative, here with the positive. If you are not that much good in factorization, we will make a video about factorization pretty soon, of course. So the first bracket will lead to a fractional value of n. I don't need the fractional value, so I will cancel that, is not possible. So, but n minus 6 equals 0 will lead to n equals 6, and this is the correct answer. So U6, or the sixth term, is equal 45. Okay. We'll go on with next question. Term by term rule of the sequence given by that. Un plus 1 is un plus 2. Un plus 2. Any term came from the previous term and adding 2. So explain that what he means, that each term is 2 more than the previous. Each term is 2 more than the previous. Okay, previous term, of course. That's the explanation. Or you can write that in any words you want, but I need the correct meaning. Like you can write, I can obtain any term by adding 2 to the current term. Okay. To get the next term, add 2. Or just add 2 for each term. Any set of words that make the same meaning is correct answer here. Number B, given that U3 is -4. Okay, he gave us -4 here, and he needs the next 2 terms and the previous 2 terms. I need first, second, third, fourth, fifth. So this is the answer of B. So I will add 2 to -4 to reach -2, add 2 again to 0. And when you go back, subtract 2 to know the previous term. If I go back by adding, so by subtracting 2, it would be -6 and -8 here. So that follow the rule, because from term to term, I add 2, and at the same time, the third term is -4 as he gave us this given. Is that clear? Again, to get the most of the video, pause each question and try to solve that yourself before you hear the answer. Now, with a special type of questions and a special technique we need to follow in the test, if this came up, be careful here because it has some calculation. He said, write down the following recurring decimal as a fraction. To do that, consider this answer is x. Now x is written as recurring decimal. That means x equal 0.888 repeatedly to infinity. Okay. I need to express that as a fraction a over b. So here's a trick. Isolate only one item from this pattern. Like the pattern here is single digit. So isolate single digit. This trick can be done by multiplying by 10 here. So it will be 10x simply equal 8. This multiplication by 10, of course, we'll move this decimal point 1 digit to the right. So it will be 8.8888888. This number of 8s is also infinite. Okay. Okay. Now we can cancel this all repeated 8 by simply subtracting those. I'll subtract the second equation minus the first. Okay. So 10x minus x is 9x. And the 8 point blah 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 minus the blah blah blah, it will be only 8. This all point 8 will be cancelled. That means x is simply 8 over 9, and we are done. Now we can write the term or the value of this recurring decimals as normal fraction. Okay, we'll solve this one. Try to pause and solve it yourself. I'll go directly by making x equal 0.24. These dots means both numbers repeated. So I will rewrite that as this way to help imagine what's happening. Excuse my for like pretty much like you. I will isolate one pattern like this 2, 4. I will isolate that by multiplying by 100 here, not 10. Why? Because it's a 2 digits pattern this time. So I multiply by 100. So it will be 24.24.24, not point, just 24. Okay, and so on to infinity. And again, by subtracting these last lines, the 100x minus x, second minus first, it will be 99x's. Keep subtracting, you reach only 24, and all this fraction will be cancelled with the upper one. So that reveals the value of x can be written as 24 over 99. Of course, here we can simplify that down even by dividing by 3. It will be 33 down and just 8 up. So at 8 over 33. Again, one more, this time with 3 decimals. So that will make x multiplied by what number? Guess what is the correct number to multiply by here? Because x is repeating 3 decimal 208. I know the dots is on 2 and 8, but that includes all digits between. So 208 repeats. Okay. To isolate one piece of this pattern with 3 digits, I will multiply here by 1000 to remove or move this decimal point 3 digits to the right. So 1000x, it will be 208.208, 208, 208, and so on. So x will came out of subtracting again, second minus third, to be 999x, not only x, equal to 108 minus 0, and all the rest here. You can see this fraction, and this fraction will be cancelled with each other. And we will end at this point that x equal to 108 divided by 999. And this is the simplest form. You can't simplify that any further, I think. 208 divided by 999. It's the simplest form. Okay. Again, try to pause and figure out how to solve this one. So if x equal 0.18, this decimal only here repeats. 1 is not repeating. It's not 18, 18, 18. It will be 0.188888. 8 only repeats. 8 only repeats. So I will try to isolate this pattern, but that will happen into 2 different steps. First, I multiply by 10 to isolate the 1 because 1 doesn't belong to the pattern. So it will be 1.8881, 1 digit only with the right, and then multiply by 10 again. Why not 100? Because I need to see the repeated fraction twice to subtract and cancel it. So this repeated decimal here, 8 will appear again in the next line. It will be 100x now, and move this decimal point more digit, okay, to the right. And now we can see the decimal fraction appears in these two lines only. Okay, so I will use subtraction again for these two lines only, second minus first to make it positive. So 100 minus 10 is 90x, not 99. 18 minus 1 is 17, and all these decimals disappear now. So the fraction we seek is like 17 over 90. Okay, and of course you can try that on a calculator. If you write 17 divided by 90, look at the answer. How will that look like? It will be 1.888888. This line at the middle, at the end, sorry, came out of approximation, but it's repeating 8. Okay, start with 1. Okay, next one is tricky. Try to solve it yourself again. Okay, if you try to write this number as it appears, it will be 1717171 to the infinity, adding that to 717171 again to the infinity. You can find easily that 1 plus 7 is 8, 7 plus 1 is also 8, 1 plus 7 is 8, and so on. Okay, you can choose 1 plus 7. So the result will be that number will be 0.888888, which can be written as 0.8 that we already solved now, which equal 8 over 9. Okay, you can find that 2 minutes ago. Okay, I hope you got this correct yourself. Now, here's with some philosophical questions. Jessica, teacher, asks a class to find the largest number that is smaller than 4.5. Jessica's friends, Jiva, gives the answer 4.4. Pretty like Novi's answer. Is that correct? No. Why she is not correct? Simply because we can find easily any number we need of numbers between these two values, simply by finding the average, for example. The average will lie exactly in between them. So it will be 4.49, for example, okay, or 4.5. This average, of course, is more than 4.4 and less than 4.5. So that means 4.4 is not a good answer, or not the number that is directly below 4.5, because there's some numbers between, and you can repeatedly find the averages of 4.45 and any of those values to find another value and another for infinity. So 4.4 is not a good answer. Next part, Jessica's friend Ryan now suggests that the answer is 4.499999. Get tired of right nines and stops. But the same, because 4.499999, add some lines here, simply you find a value that is between the value that Ryan said and the teacher said. So 4.5 and 4.49999999 that I wrote is much closer than the values Ryan said. So what is that is written to infinity? Like 4.499999 to infinity. Repeating 9 is repeats a lot. Okay. Is that a good answer? It seems yes, but Actually, it's no. Why? Because 4.4999999 here is simply equal to 4.5. What? Yes. What I said, 4.5 is equal to 4.49 repeatedly. Okay, let's prove why that both are equals. If I mentioned that x equal 4.49 with dot here, I will multiply by 10 first. It will be 10x equal 4.9 and multiply by 10 again. It will be 100x equal 449.9. And if I subtract those, I will find 90x equal 449 minus 44. How much is that? 449 minus 44 is 405. And the decimals will be cancelled. So x is 40 and 5 over 90. And if you try that on a calculator, what's 405 divided by 90? Surprisingly, it will be 4.5 again. So x is 4.5. And that's prove my answer, that this number equal to 4.49 to infinity. So what do you think is the better answer? No answer. Surprise. No correct answer for this question. No real number you can say, or at least write, that is directly below any other real number, 4.5 or any other. Like what's the number that following 2 directly, you can't say an answer. What's the number before 10? There is no answer. So what's the number that's directly smaller than 4.5? There is no good answer. Whatever answer you write, I can find a number between your answer and 4.5, simply by finding the average of those numbers. So there is no direct number. The real numbers are pretty close to each other in a way that we cannot mention the difference between any two consecutive real numbers, or even mention the word consecutive real numbers. There is no consecutive real numbers. There's consecutive integers, 1 followed by 2, followed by 3, followed by 4, but no one can say what real numbers following the one no number. 1.1 is not the answer, 1.01 is not the answer, 1.00001 is not the answer. Okay, so no real number that directly follows 4.5 or before 4.5. Okay, pretty nice question here. What are rational and irrational numbers? Rational numbers, that all numbers that can be written on this form, a over b, where a and b are both integers. None of them, not none of them, at least b is not equal to 0. So 1 over 4 will follow this rule. This also can be written as 4 over 1, so it is rational. Negative 7 over 1 is also rational. This one also can be 3147 over 1000, which is integer over integer, so it's also rational. 0 over 1 is also rational. This one 3 over 8 rational. This one also rational, because you can consider that over 1. This one can be written as negative 67 over 100, also rational. This one can be written as 0. Like 45 over 100. Okay, the square root of 25 is 5, which can be written as 5 over 1, so it's also rational. Any number can be written as a ratio is rational. I can see one more here that can be written, yes, as 9 and 45 over 99, which is like if you write that here in a calculator, 9 with 45 over 99, or you can use the method we just learned. It will be 104 over 11. Okay, 104 over 11. So since we can write that as integer over integer, so it will be also rational. So we left with some numbers that we can't, like pi that we used in finding the perimeter and the area of circle is not a rational number, it's irrational. Also, root 3 cannot be expressed as fraction. This number also, pi and 2pi and any multiple of pi is not, root 2 and any multiple of root 2 is not. Those blue are irrational numbers. And imagine that irrational set is much larger than rational sets. We have infinite number of irrational times the rationals. Like any rational will lead to infinite number of irrationals. So pretty dense set, pretty like between any two rational, you can find infinite number of irrationals. So it's much larger set than rational numbers. But here, just a few examples for it. Okay. In this question, show that the following numbers are rational. As we just mentioned, rational can be rational only if we can set that on a form of integer over integer. So let's try 6. 6 is 6 over 1. So not done. This is a mixed fraction, and simply you can multiply 2 by 8. 16 plus 3 is 19. You learned about that before. So 19 divided by 8 is a rational number. And this one and 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, you can say that equal x and multiply by 100 and find that 11. We'll see that. I will write this one as 12 over 99, or divide by 3 as 4 over 33. So I think 37 over 33 is the value. 1 times 33 plus 4. 1 times 33 plus 4 is 37. So this is a value for a rational number. 0.8 decimals, again, it's 8 over 9. We just answered that twice now. This one is 427 divided by 1,000. Integer over integer, so it's a rational. 3.14 in recurring decimal, so it will be 3 and 14 over 99. Of course, it's 3 times 99 plus 14. How much is that? It will be 311, which is proof that this number equals 311 over 99, and that make it also rational. Of course, in the test, you will solve this recurring decimal the normal way we did, okay? Like convert that to fraction first using the Igcse method that we did, and then say it's a rational at the end. Okay, here's just a shortcut for that. With the last question in this video, find a number in this interval so that is a rational. So I will find plenty of numbers for you. Rational numbers between that, you can choose any negative fraction or positive fractions that between -1 and 3, or even 2 and 1 and 0 are all rational. Okay, we learned that 2 can be 2 over 1, which is rational. Number B, a real number that but not a rational number. You can choose here real number like square root of 2, cubic root of 7, or yeah, so it will be below 3, below 8. Below 2, I think. And pi, of course, no, pi is more than 3.14. But pi minus 1 is working fine, okay? Pi minus 2. The square root of 7 over 5, for example. Any of these will be irrational number. B, irrational. C is an integer like 0 and 1 and 2. These are the only integers here. Integer means a whole number. Natural number like positive integers. So D will be like 2, like 1. Okay, a natural number. Of course, we don't have negative integers here. So start with -1. -1 even is not equal x. So can include that in the answer of numbers. Okay, my dear, this is the first part of the chapter. We are looking forward to make a video for the sets pretty soon, inshallah, this week. Thank you for watching and see you next video. Enjoy and don't forget to make subscribe and write any comment you have. Thank you. See you. Bye-bye.